Hello and welcome back to my YouTube channel, guys. Today we are going to see our next calculation for a simply supported beam. In earlier video we have shown how to calculate a motor power for overhead conveyor. If you like to see that video, the link is given in the description box. So we are going to see a beam design. Here we have considered a trolley which has four wheels. At the bottom, we have considered for the better understanding two wheels and one beam which is carrying a total load on the beam. So here you will see we have one beam here and these two wheels are connected to the beam from the bottom. Now we have considered a 600 kg load of our product on the beam. And practically, the load is uniformly distributed on the beam, but for the safety factor purpose, we have taken the load in the center of the beam. Now we will see what are the considerations we have made. Here we have selected a tube size 100 by 4 thick, which is a square tube. From the square tube catalog, we are finding out this data. Z, which is the elastic modulus, A is the modulus of elasticity, I is the moment of inertia. Length, as per the design, we have find out the length we required is 2200 mm and the load on the tube is 600 kg. In this chapter, we will see how to calculate maximum bending moment, bending stress, deflection, and we will check if design is safe or not. Now we will see how SFD and BMD works. This is the diagram where we have given here a beam. There are two reaction force RA and RC is acting opposite direction to the load direction. We will have some considerations here. The upward load we will consider positive and downward load we will consider negative. So while finding out a SMT diagram, here the first load which is acting at point A, which is called reaction RA, is positive. So we will consider this as a positive side. After reaching to the certain load point, it goes straight because this load is constant up to this point. Now at this point B, the load W is acting downwards. So downwards we have considered a negative sign. So from neutral axis it will goes to the downward direction. So we need to connect these 2 points from positive side to negative side. So this line forms. Again from point B to C, the load is constant. So this line goes straight, and at point C the load goes to 0 because of reaction RC. So you need to always consider, so whatever the load is acting on the point, there is a equal reactions from opposite side. So here W by 2 formula get formed. Now we will see bending moment diagram, which is called BMD. So for the bending moment, we are considering again another notations like we have considered here. So from a fixed point, whatever the loads are acting clockwise, we are consider them positive, and whatever the loads are acting anti-clockwise, we are considering them negative. So here in the case at point A, if we consider a fixed point, then W is acting at clockwise direction. So here the positive sign occurs. So at the bending moment, this neutral axis to the point load, it goes into the positive direction. So the formula becomes W L by 4. Now we will see how to calculate maximum bending moment. Now we have understood how the SFD and BMD comes and how this WL by 4 formula where it comes from. Now maximum bending moment, WL by 4, load we have 600 kg and length of the beam is 2200, and we are dividing that by 4. Now the answer is 330 into 10 raised to 3 kg mm, because 2200 is in mm and 600 is in kg. Now we will see how the bending stress will be find out. So the bending stress formula is M by Z. M is nothing but a bending moment and Z is nothing but the elastic modulus. So we have already calculated the bending moment M is 330 into 10 raised to 3, and Z from a beam catalog, we can get this value 45.268 into 10 raised to 3. So this comes to 7.28 kg per mm square. Now, as per the industrial steel BS standard, it has to be 10 kg per mm square max. So you have calculated 7.26, which is less than 10 kg per mm square. Bending stress in the beam is okay. So now we will see how to calculate a deflection delta in a beam. So delta equals to WL cube by 48EI. For this formula is for simply supported beam. So we will put the values. W is 600 kg, L is 2200 raised to 3 divided by 48 into E, which we have taken from a standard catalog. So E is 20.38 into 10 raised to 3. Similarly, we are taking I from the standard catalog, which we have found the value is 226.33 centimeter raised to 4, which is a moment of inertia. So now this is our formula, which we have put a value in that, and we are getting 2.89 millimeter is a deflection in a beam. Now we will check for design. Now guys, we have calculated a bending stress, which is okay with the BS standard, but now the deflection which we have calculated, we also need to check which is safer or not. Now we will check for design. So L by delta means length upon delta, which is a deflection. This ratio has to be greater than 375, which is a standard value from BS standard. So 2200, which is a beam length, and 2.89 is a deflection. So 2200 divided by 2.89, value comes which is greater than 325. Hence, this proves that our design is safe. You can check for lower beam size also, because if you remember, I have taken 100 by 4 thick square tube for this calculation purpose. Now you need to check by number of iterations that how much lower size of the beam you can select for your design. So that's it guys. This is a simply supported beam from our side. Please do like and subscribe to our channel to get our latest uploads on time. See you. Take care.